How does geological history shape drainage basin patterns? Imagine a landscape shaped by forces from millions of years ago, where the land story influences how water moves today. That's what we're exploring, how geological history creates the drainage patterns we see across the world. Think of a drainage basin as a giant puzzle piece, collecting all the rain and guiding it toward rivers, lakes, or oceans. But these pieces aren't random. They are shaped by the rocks, landforms, and past events that carved the landscape long ago. The type of rocks in an area plays a big role. Hard rocks like granite are tough and resistant, forming ridges and highlands that act as natural boundaries between basins. Softer rocks like shale or limestone are easier to wear down, creating valleys and channels where water flows more easily. The way these rocks are layered or fractured depends on the region's geological past, influencing the direction water takes. Tectonic activity, which involves the movement of Earth's crust, also leaves a lasting mark. When mountain ranges from through uplift, they create steep slopes that cause rivers to flow quickly and carve narrow valleys. On the other hand, when land sinks or subsides, it forms low-lying areas like basins or floodplains where water can gather and spread out. These tectonic shifts from millions of years ago shape the overall layout of drainage systems. Glacial activity during ice ages has also played a big part. Glaciers can gouge out deep valleys and deposit debris that blocks or redirects water flow. When glaciers melt, they leave behind landforms that influence how water moves, creating new pathways or barriers. Over time, rivers and weathering continue to reshape these landscapes, changing the size and shape of drainage basins gradually. The structure of the rocks underneath influences the pattern of drainage networks. For example, a dendritic pattern looks like tree branches, forming on uniform rocks where water can flow freely in many directions. A radial pattern occurs when water flows outward from a central high point, like a volcano or dome. Trellis patterns develop in areas with alternating resistant and weak rock layers, causing streams to run parallel with occasional tributaries joining at right angles. Rectangular patterns happen where faults or joints in the rocks create a grid-like network for water to follow. Understanding this history is key when mapping watersheds and drainage basins. It helps us predict how water will flow, where flooding might occur, and how ecosystems depend on these water routes. Knowing the geological past gives us a clearer picture of the landscape's water systems, making it easier to manage water resources and protect environments. In short, the story of Earth's geological past shapes the landforms and rock structures that guide water's journey. These ancient processes influence the patterns of rivers and streams, creating the diverse drainage networks we see today. Recognizing this connection helps us better understand how water moves through ecosystems and climate systems across different regions.